This is section 3 of chapter 8, markdowns, multiple operations, and perishable goods. Markdowns, a price reduction from the original selling price of merchandise. And a reason for this may be error in initial pricing or merchandise selection. Markdown cancellation is raising prices back to the original selling price after a sale is over. And the selling price is promotional price of merchandise after a markdown. Determining the amount of markdown. To find the amount of markdown, take the original selling price and subtract the sales price from it. So we have a coffee maker that originally sold for $59.99 and was marked down to $47.90. What is the amount of markdown? The original sales price is $59.99, and we subtract the $47.90, so the markdown was $12.09. Determine the markdown percent. We're going to be using this same thing that we did in Chapter 6, that rate of decrease, and we can use our proportion triangle where we have the amount of the markup is a portion and the base is the sales price, and then we have the rate. So to find the markdown percent, use the percentage formula. Rate equals proportion divided by base, where the markdown is a portion and the original selling price is the base. So to use this, what is the markdown percent on a pack of pens selling for $2.99 that originally sold for $3.69? So the markdown is the original price, $3.69, minus the selling price is 70%, is 70 cents. So then we can have the amount of the markdown and divide it by the original selling price, which is the 70 cents divided by 369, and it's 19%. Determine the sales price after markdown. To find the sales price after a markdown, use the formula proportion equals rate times base, where the sales price is a portion, the original price is the base, and 100% minus markdown percent is the rate. So original selling price times 100% minus the markdown percent will give us a sales price. We can again use our triangle where the portion is the sales price, the original price is the base, and then 100% minus the markdown is the rate. Well, a mega store originally sold packs of t-shirts for $15 each. That's the original sales price. If the packs were marked down by 25%, what is the sales price of the shirt? So the portion or the sales price is unknown, and we do 100% minus the markdown percent, so it's 75%. So 15 times 75 cents is $11.25. So again, our triangle, the sales price is unknown, the original price, and then 100% minus markdown is the rate. You can go to your textbook to page 248 at the bottom, and at the top of page 249 is a try it exercise. So you can go through and try that and check your answer on page 260, so you can pause the presentation to do that. Next, we're going to determine the original price before a markdown. To find the original selling price before a markdown, we use the sales price formula, solved for the original selling price. So it's the sales price divided by 100% minus markdown percent, or again, our proportion being sales price, base, original sales price unknown, and then 100% minus the markdown. So what was the original selling price of a laptop case currently on sale for $48? That's our sales price after 35% markdown. Round your answer to the nearest cent. So our sales price is 48, 100% minus the markdown would give us 65 cents. Divide that into the sales price as $73.85. We could do the same thing with our triangle. Sales price 48, 100% minus 35 is 65 to get our original sales price of $73.85. You can go to page 249. Exercise 14. You can do the try it exercise and check your answer on page 260. This is finding the selling price after a series of markups and markdowns. We have staple goods. They're usually marked up once, marked down occasionally, on sale. Products considered basic and routinely purchased that do not undergo seasonal fluctuations during sales. And then we have seasonal goods. Those are fashion items, bathing suits, holiday merchandise, products that exhibit seasonal fluctuations in sales and may undergo many markups and markdowns during their selling season. When solving a series of markups and markdowns on seasonal goods, remember that each markdown or markup should be based on the previous selling price. So in September, we have a tire shop that purchased snow tires for $48.50. That's our cost. And the original markup was 55% based on the selling price. So that the selling price would be 100%. In November, we marked them down 30%. December marked them up 20%. February marked them down 30%. In March, we cleared them out at 25%. So we want to know what was the final sales price of the tires, rounded to the nearest 100. We can use our box and put in our known items. We know that the original cost was $48.50. We know that we're trying to solve for the selling price, and selling price is based on 100%, and we have a markup at 55. So we subtract to get our 45% of cost, and then we use our square, the outer corners, 45x equals 48.50 times 100. And when we work it out, we get the same thing as if we had used this formula, 107.78. And then we use, this was the price, so we're going to use that for the previous price. And then the next percentage was 30%, so 100% minus 30% is 70. So then it's 75.45 is the selling price. Then we use that selling price for the December. We have a markup, so we're going to add 20%. So it's 1.2 times 75.45, and the selling price is $90.54. We use this selling price to figure the markdown in February, and again will be 70%. We get 63.38. Use that selling price. We have a markdown in March of 25%, so that would be 75% times 63.38, and our final selling price would be $47.54. We're going to be looking at perishable goods. So these are products that have a certain shelf life and then no value at all, such as fruits and vegetables, flowers, dairy products. So to get the selling price of these perishable goods, we take the total expected selling price, divide it by the total quantity minus the anticipated spoilage. So we have a flower shop that purchased It says 800 dozen roses at a cost of $6.50. If a 10% spoilage rate is anticipated, at what selling price per dozen must the roses be sold to achieve a 60% markup based on selling price? So that's 100%. So there's our formula. We can use our markup table, have we know what our cost was. It's 800 times the $6.50 per dozen, so it's 5,200. And we also know that we're looking for our selling price, which is our unknown, and it's based at 100%, and we want a markup of 60%. So cost markup would be 40%. So 40x times 5,200 times 100. And we get the exact same thing, 13,000, if we use the cost over 100% minus a percent of markup based on selling price. 13,000 is our selling price. Now we can use that information now. We want our anticipated spoilage, we said 10%, so we bought 800 dozen, so it'd be 80 units. Now we can take our total expected selling price, which is 13,000, and divide it by the 800 minus the 80 units, so 720 is what we would expect that we'd be able to sell. So we'd need to sell them at $18.06 per dozen to get a 60% markup. Okay, these are the review problems. A jewelry store purchases watches for $53.07. The selling price is $89.95. That's our selling price. What is the markup, and what is the markup based on cost? So we can use our square again. We know our cost is $53.07, and that's based on 100%. We know that the selling price is $89.95. We're trying to solve for the markup. So we know that $89.95 minus $53.07, that would give us our markup price of $36.88. And so then we would take our square, 100 times $36.88, and $53.07 x, and when we solve for it, we come up with 69.5%. A store purchases sofas for $328.25. If the store policy is to mark up all merchandise 33% based on selling price, what is the retailing selling price of the sofas? So its selling price is cost over 100% minus the percent markup on sales price, based on sales price. So we have the selling price of $328.25, the cost. 100% minus 38% would be 0.62% based on selling price. It would be $529.44 would be the retail selling price. We can use our box again. Our knowns, we're looking for the selling price based on 100%. We know what the cost is. We know that we want a markup of 38%. And so when we do the subtraction, we get the markup percentage based on cost is 62%. This is going to be a series of markups and markdowns. And this is golf clubs, $453.50 per set. The original markup was 35% based on selling price. In April, we marked down 20%. In May, we marked up 10%. In June, we had a sale of 15% off. And then in July, we had a 10% markdown. So what was the original, what was the final selling price? So once we figure out our first one, then we're just working off of the previous amount. So we know the cost was $453.50. We know we're trying to solve for the selling price based at 100%. And we have a markup, I think it was like 35% markup. So when we subtract, the markup based on cost is 65%. So 65x 453.50 times 100, and we solve, we get the same as we use this formula. Then we use that price, and we had a 20% markup, it would be 80% times that. Then we use this selling price, we had a 10% markup, so it's 1.1 times that selling price. We use this selling price for our markdown of 15%, which is 85%. And then we use this price, and we had, our final one was a 10% markdown, which would be 90%, $469.68 was our final selling price. The last one we have is on perishables. A market purchased 460 pounds of sweet potatoes at 76 per pound. If a 10% spoilage rate is anticipated, at what price per pound should the sweet potatoes be sold to achieve a 35% markup based on selling price? So our cost, 460 pounds times 76 cents, was $349.60. So we take our $349.60. We know X was based at 100%. We wanted a 35% markup. So then our sales percentage based on cost was 65. And then we solved for our four corners. And when we work it out, it will be the same as if we use the cost divided by 100% minus the percent markup based on sales price. $537.85 is our selling price. Now we need to find out how much, what is the percentage of spoilage. It stayed 10%, so 460 at 10% is 46. And so we do 460 minus 46, so we're going to be able to sell 415 and divide that into the selling price. So we need to sell at $1.30 per pound. $1.30 per pound. That is the conclusion of Chapter 8.